Hi, I'm Varun Singh and I'm the programmer of FTC Team 4997. I'm going to give a brief tutorial on getting started with the new Android system and going to show you how to write your own Teleop program. So let's get started. So the first thing you want to do, if you haven't done it already, is download Android Studio. So type in Android Studio up in Google, then it should pull up this download Android Studio and SDK files. And then you can just download it for whatever operating system you have and just go through all of the default, choose all of the default values and files. After you download Android Studio, you're going to want to download the FTC SDK. So if you come over here, type in FTC Android SDK into GitHub, it should pull up this entire thing. Now if you're not familiar with GitHub, then the best thing to do is just click on this download zip file over here and just download it to a folder inside your inside wherever you want in your computer. So I just put a folder in my documents saying FTC SDK and unzipped it into here. So when you go through Android Studio, you're going to come up with right here when you open it for the first time. So you can click Start a New Android Studio Project and just click type in a just leave it as the example that they have, like my application, and then your domain is necessary. It has to end in something like .com, and this is just the way for Android to put it on your phone. You don't have to worry about the name so much. So when it comes over here, it doesn't matter what this all is. You can just skip straight through, make sure it's on blank activity, and click Finish up here. This should open a new Android Studio project where you can create apps, and from here I'll show you how to open the FTC SDK. So when you open Android Studio, you're going to want to, it's going to show up something like this when you open it up. And what you need to do is come over here to File, and then you're going to want to Open. So when you go to Open, you're going to want to navigate to the folder that you installed the FTC SDK right over here. And then you're going to want to just open this. After you open this, it should come up with something similar here, except it'll be all blank here. And down here, there might be an error message. In case there's an error message, what you need to do is come over here to Tools. You're going to come over to Android and come down to SDK Manager. When you start SDK Manager, you're going to end up with something like this. There may be some updates that need to be done, so you can just update those first. And then after that, chances are you're going to have an error message for something called API 21. So in order for that, you're going to have to come over here, find the group that says Android 5.01 API 21, and click the SDK platform and this Google APIs, and then you're going to want to install them. And that should clear the error messages. So once you update the APIs or install them, then come over to here to File, New, and Import Project. You're going to want to once again find where you installed your FTC SDK. Click on this right here, FTC App Master, and find this build.gradle, and you're going to want to open that. And that should pull up a screen that looks something like this. You might not have all of this open up here, but that's okay. If you want to open these things, you come over here you want to click on Project over here if it's not open, and FTC Robot Controller right here, Java, and then there's this com.qualcomm FTC Robot Controller, And then under this, there are op modes. So under this folder, you can find a variety of default op modes, such as K9 line, K9 tank drive. And so you can just open them up. And so for example, this is the K9 Teleop default program. And this is the K9 tank drive. Once you're here, it's similar to Robot C if you're familiar with that, but then there's a few key differences. So each op mode is a separate program. So for example, K9 tank drive, this will be this is one program that is your Teleop program, and this time in tank drive. But you're not going to want to use all of these default programs because most of your robots will be differently configured. So then you're going to need to create a new op mode. And each op mode is stored in something called a class. So the way you do that is you go to File, New, and then Java class right here. And then you just want to type in the name of your op mode. For example, Teleop test Teleop, and you just want to leave the last end every op mode in op, so that way you can be sure what it is. So when you open a new op mode, this is what shows up. Right here is the name of what you have, and we have to, in order to get something that we want usable, we can just copy a lot of this default program and then change whatever we want. So just come up to this import statement, we can just copy all of this and highlight these two things, and then it shows all of this. It just copies straight all of this. But what we notice is that here it says K9 tank drive rather than test Teleop. One thing in Java that needs to be done is the class name must always match in both places. So we need to replace all instances of K9 tank drive with test Teleop. And so it should show up once here and then once here under something called the constructor. So now everything is configured for this Teleop mode, and it will work exactly the same as this K9 tank drive. So now we can go through the details of how the program works. So the first thing we have under here is some variables stored under final static double. Those are just characteristics of those variables. They're not too important to understand right now. But right here we have the variable name. Right here is arm min range, and then it's assigned a value, 0.20. And then if we look up, FTC was nice to provide us with some good comments. So right over here it says that for the default thing, that as the servo value is from 0 to 1, and so 0.20 would just be a specific servo value. And then we have different servo positions that we can rename. And then right here, double arm position, that just stating another variable of where that we can define later. And arm delta right here is how much we want to change the servo by. So every time we click a button, we want to know how much the servo should change. That's basically the rate of change. And then they do the same thing with this second servo, which is called the claw. Now once we get here, this is where we actually define what our different what the different configurations are. So we could just have to type in DC motor and then the name of the motor, and servo and then the name of the servo. So here they define a motor right as a DC motor and motor left as a DC motor, and then claw and arm. If you want, you can also add DC motor as in, like, if you wanted lift 1, and then DC motor lift 2. So you can just add or remove whatever you like. This constructor is just a default, you don't want to mess with it. And then we come over here to this public void start. So this is what your robot does. This is kind of initialization. So when you click on when you start the op mode, this is what runs at the very first time. So what we put here now is the first thing we notice right here is something called a hardware map. What this is telling it to do is once you configure it from the app on the robot controller itself, it's going to look into that app and find out what kind of things you have attached to it, and then it's going to assign those to these variables that we created on these DC motors. So what we're doing is we're getting the motor called motor_2, and we're defining that as motor right, and we're getting the motor left and defining it as motor_1. And so I'll show you guys how to do this on the app in a little bit later. And then right here we have this set direction. What this is telling it to do is if with left and right motors, typically one side is opposite of the other if you're going forward. So all you have to do is type in DC motor.direction.reverse, and that'll just flip it around for you. And then here we have naming these arm and claws and defining it as what the actual hardware values. And then right here we're starting initializing these arm positions and claw positions for the servos. So this, once we're done with public void start, this brings us to the loop. So one thing that's different in Java as opposed to Robot C is the way this loop function works. So traditionally in Robot C, you would have something like while true, and it'll cycle through that. And every time you set the motor, like say halfway through the program, you tell the motor to be at 50% power, the motor will immediately go to 50% power. However, here with the loop program, this automatically has a while true, so it's looping through this entire thing. But it goes through entire section. It goes through one run before it updates any values. So if halfway through the program you tell the motor to be set at 50% power, and then later you tell it to be set at 75% power, then it's only going to set it at 75% power because it updates everything at the end. So all motor values are sent out at the end, and any sensor values that you are trying to retrieve are pulled in at the end of one run. And it repeats this over and over again. And approximately 30 milliseconds is the run time according to FIRST and Qualcomm. So then we can look at the more specifics. Right here, float, that's like another variable. We have left. And so this is just gamepad1.leftStickY. So if we pull up a controller, so that's just going to go, it's just as described. So this is the left Y, this is the right Y, and then we see all these buttons. What's different about them in here is we just name the buttons as they come. So gamepad1.B or gamepad1.x, those are how we name the buttons rather than saying button 1 or button 2. And in these controllers, up is -1 and down is 1. So it goes from -1 to 0 to 1. And so if we want to have the standard where up is forward, then we're going to have to set in the program, we're going to have to see right here it includes a negative sign, so that way it goes the right way. Now once we get these left and right and we define them as these values, we're going to want to clip the range from -1 to 1, because the motor values can only read from -1 to 1 as opposed to -100 to 100. And then we have this set power. This is just telling it to go at the end of the entire loop iteration. It's going to set the power of these motors. And over here we have a bunch of if statements, where if this button is pressed, then we see that the arm position will be increased by arm delta, which is the rate of change that we defined above. and similarly it'll be decreased if the button Y is pressed, and so on. And then left bumper, that would be the corresponding to left bumper on the controller, so it's, and left trigger, so it's simple to see how this correlates. And then finally we have it clipping here the range from the arm min range to arm max range, so that way the servo doesn't go out of the specified ranges and hit some and break itself. And then finally we're setting the position. Down here at the very end we're going to have something called telemetry, and this is where specific data can be sent to the driver station, so that way you can view different values. So the way it works is you define kind of what you're talking about over here in the left in quotation marks as a string, and that's just kind of what you want, what you're going to refer it to, and you're going to do a comma, and then this next string is what's actually going to be displayed. So you're going to have, so this is what you call it, but this is what's actually displayed. So we see that this is going to display 3 asterisks, then robot data, then 3 asterisks. And over here, it's going to display this arm with this colon, and then it's just going to, this string format is basically taking the value of the arm position that we had earlier and set to the servo, and then just parsing it into a string, so that way it can be displayed on the controller. Then finally we have this stop method, and that does typically you'll have nothing. That just whenever you click stop on the robot controller, the driver station, then it'll execute whatever's there as the last minute. So if you want to, when it's finished, you want servo values to go to specific positions, then you can just set that there, or initialize variables or things like that. But typically it shouldn't be very important to use. And then down here, once you learn, if you don't know Java already, there's different things called methods. And so down here you can add your different methods to reference up in the start, loop, and stop. Now I already created a 4-wheel drivetrain testing op mode that I'll show you working in a little bit, but I just want to go through the changes I made to the default K9 tank drive, so that way you guys can see easily how to change your own. So rather than deleting all the code I didn't need, I decided to comment it out just in case I'll need it later. If we go through, we'll see that I declared these DC motors, and then I named them as motor left front, motor left back, and so on. And I'm not using any servos for this, it's just a drivetrain. I'm leaving the constructor intact, and then I come over to start. So here you can see that I'm on the robot controller. When we write a configuration file, you can name the motors there. So the one that's labeled M1 will be mapped to motor left front, and so on. And all the left motors I'm reversing here. And since I don't have any servos, I don't need to initialize any values. Now once we get to the loop, we'll see that I have a left power and right power. And once again, I'm going to correlate these to the negative of the joystick values. And I'm going to clip them from -1 to 1 just in case. And then I'm going to set all of these motors right here to those powers. So both left motors will be assigned left power, and both right motors will be assigned right power. I commented out all of this arm and claw, these servo values. And then right here we get to the telemetry that will be displayed on the driver station. So we can see that I just commented out all the arms and the claw values and kept the motors. And then stop I left as nothing. In order for, once we create our own op mode, we want it to be able to be displayed on the driver station, because you're allowed to select which op mode you want, and you have to make sure that it shows up. So if we come over here to the left, look up for FTC op mode register. What this just does is choose which ones to display. So I can go to manager.register, and then I can just type in the name that I want it to display as, for example, test Teleop, and that'll be a string. And then I type in the test Teleop, and then I end in .class because that was a class file. So that will enable it to show up on the driver station. I'll just, since I'm not using this, I'll just delete it, but you can see how I already put in this test 4-wheel drivetrain op and test 2-wheel drivetrain op. So FTC provided some nice documentation that we can access. If we go to FTC SDK, which is what I saved the folder under, FTC App Master, come down here to doc. We can see that they provided Java documentation. So we can open, for example, the index, and that should open up the, we can see all these packages, classes and stuff that we can open and get more descriptions. For example, the DC motor controller class shows all this information. They also provided the APK and then these tutorial files. So there's a build guide for the default K9 bot, a brief guide to the next generation, and then what I found really helpful, this FTC training manual. It's 103 pages, but there's a lot of useful information, like many of the stuff I talked to you about here. So if you want any clearer screenshots or just want to see it in writing, most of it is available here. So before we can start using the phone, we have to set it up. Gears Inc. has a really nice video on how to do this, and I'll put a link to the description below. But I also have some additional setup features that I'd like to show you. So once you do the initial setup, we want to make it very nice and easy to use. So the way we can do that is if we come over to settings, which it can be swiping down on the notification bar and clicking that button. We want to make sure that airplane mode is on. Wi-Fi is here. If we want to do Wi-Fi direct, we have to come down to here, click Wi-Fi direct, and now we can rename the device right here. So if we don't like, so here this is the robot controller, so I labeled this 4997-RC. The driver station would be named 4997-DS, and we can see that it's connected right here. Some other things I did was I came over to display. We want to, usually it starts out with auto rotate. We want to make sure it's not on auto rotate. And then we can come over to apps and we scroll all over to here. So there's a lot of apps that you can disable because they're not necessary, and it should make your phone slightly faster, or at least remove a lot of the things that you don't want to see. So you guys can pause the video if you like and then go through all of the various disabled apps and disable them on your own. So once you've disabled the apps, all of those apps, you can come over here to this right here where all your apps are. I actually downloaded from the Play Store a clock widget, which is the digital clock widget right here, and I just set it up right there, so that way I'd have simple, easy to read time. And then I also downloaded the FTC robot controller for this phone. On the other phone, obviously, you download the FTC driver station, and I just put that as the only app here. Also, usually you start out with 5 home screens, and so the way you can do that is you just zoom out, and you have to have a minimum of 3. So I found that this works best. And then you might want to put like a team picture on the background. Now we can open up the FTC Robot Controller app, and we see that it has a lot of information right here. And so I'll go over to the actual hardware and show you how to connect it now. So once we create the op mode and we upload it to register, we want to download it on the robot controller. That's the phone that's going to be on the robot. So if we have this right here, I have plugged it into this wire already, and we can just plug it into here. Now, if you follow the configuration directions of the GearZync video, you'll know to already turn on any USB debugging. And then what you want to make sure is that if you come over here to Tools, Android, make sure it's Enable ADB Integration, and then Android Device Monitor. Right here will enable to make sure that you have your phone connected. So when you download the file, you want to make sure that you don't have this FTC robot controller open. Just close that. Then what you want to do, once it's plugged in, you want to click play right here. You'll see Gradle executing tasks down here, and then it'll ask you to do that. And then you'll see down here it says Gradle Build finished moments ago, and then if you look on your app on your phone, it should have opened the FTC robot controller app. So that's when you know that it's been downloaded successfully. So this is our test robot, and it just uses 2 core motor controllers connected to the core power distribution module using like the wiring diagram that they provide when you get the kit. And then we have 4 motors. All the right motors are connected to one controller, and the left motors are connected to the other controller. Now we can hook the phone up just like this to this USB ODG on the go port. And then we can turn on this from the core power distribution module. And can you see the phone properly? Okay. So now we want to set up a configuration file. So we can come over to settings, and then right here we can configure robot. So we would press scan, and if you have this all configured correctly, but it's not, if it's pulling up an error message that it's not detecting anything, just restart your phone. But as of now, we see that it detects 2 motor controllers. So we can pull up in the motor controller, and then we know that there's 2 motors attached, so we can just enter the name. So like say M1, as I mentioned earlier when we were programming, one's named M1, one's named M2. And then for the right side, one's named M3, and one's named M4. And we just, So you can just name them whatever you want as long as you reference it correctly in the code. Then we can just click Save Configurations. I already have one created right here. But I already have one created. And we come over Load Configuration File, and we just have to click Activate. And up here at the top, you'll see Active Configuration File. And then right here, I have 4-wheel drive test 2. So you can just, whatever the name is, whenever you activate it, it'll show up right here at the top. You can press the back arrow to come over here, and then all of this is set up. And then you just want to make sure that Wi-Fi Direct, if you're connected to your other phone, it'll show up here. So this here right here is a standard driver station setup. I have 2 controllers, even though I only need one. But if the other one isn't programmed, then it doesn't matter. So as you can see, it's connected by this hub. I can just plug all of this right here. And we want to come over here to settings, gamepad type, make sure it's your whichever gamepad you have. And then on these Logitech controllers, you want to make sure that they have a switch. It's slid to the left on X. Now you have to be able to distinguish between controller 1 and controller 2. And so the way you do that is you have to come over to one controller, press start, and press and hold start and then click A. And you'll see how it flashes green here. And right here, press start and press B, and flashes blue for here. So then if we can get a closer view, so we see that these are different values of the, so if on gamepad 1, if I were to do this, you can see how the left Y value is changing. If I were to press the button X, then it's just showing up right there on the bottom. So this just shows, this enables you to detect if anything's wrong with the driver station side. On the top, we see that Wi-Fi Direct, it's connected to the 4997-RC. This ping time is very useful in case that way you can see how fast it's communicating. So you can see, I've never seen it go above 4 milliseconds, so that's pretty good. It shows a battery controller on the robot controller, so the actual phone battery level, and then the battery level of the robot. Now we can come over here to select op mode, and we can see all of these op modes, and then these two ones that I created. So we can just select the one here, test 4-wheel drivetrain op, and then all I have to do is press start, and that'll send a signal. Right here you can see the telemetry data that we programmed. So you can see how it says left power is 0, right power is 0. But if I was to, on driver station 1, you can notice how the power changes on here. It also changes the value down here where it's showing their values. And if you can hear the robot and probably see it, it's moving very well. It's very responsive because of the low ping time and it's connected directly. So I hope this tutorial has been helpful to you. If you have any more questions, then feel free to leave a comment in the YouTube video below or email us at the email in the description. Thanks for watching.